Hello, everyone. Welcome back to this short tutorials in how to use Bioflow. In the past, we have shown you how to use the data management options of Bioflow to retrieve data or new or old analysis. And also, we have shown you in other videos how to use the trial, single trial indices and OCS under the genetic evaluation section. But the focus of this module is going to be on how to calculate realized genetic gain under the selection history section. This is particularly useful when your organization want to come up with some metrics to evaluate the performance of the breeding programs after several years or generations. So to calculate realized genetic gain, I'm actually going to show you everything from scratch. From retrieving the data to running the analysis. And I'll go and first go to retrieve new data. I'm going to retrieve the example phenotypic data from some hybrids from the Genomes to Fields initiative. And then I'm picking that designation is going to be the hybrid column. I'm going to pick two traits, let's say yield and ear height. You can see the preview of my original data set. I have replicate information, I have block information, I have row information. So I have actually quite some information in this data set that I'm going to include in order to increase the heritability of my trials. I also have, location and experiment and things like that. So I'm going to compute the environment as the concatenation between year, location, and trial. I can see a new environment popping up there. And I'm going to also retrieve the pedigree information. Of course, you would need to bring your own data sets, but I'm using the example data set to show you that what would you need for calculating realized genetic gain. So you would need your phenotypic data set. You would need the pedigree file where you specify the year of origin of the germplasm that you're going to analyze. This is very, very important because the realized genetic gain is, at the end of the day, just a regression of the adjusted means of the materials over the year of origin. So this is key and needed information to be calculated. Good. So once you have this information mapped, now you can move and, of course, QA the phenotypic data. So I'm going to QA these two traits. I'm going to keep the default parameters. I have tagged the outliers. So this information has been cleaned. Second step would be that I perform the single trial analysis. So I'm going to pick that QA stamp. I'm going to pick my two traits, for the environments and that I have available in that data set. I'm going to pick the designation as the effect. And I'm going to run the analysis. This is going to take some time because it's two traits and 7 environments in each. So it might take 1 minute or two. But when it's done, then we will have estimates of the different individuals in the different environments. This can be used later on the multi-trial analysis. And this is a key component that I want to show you. So I'm going to ignore the fact that we have results, for this STA for now. And I'm going to move directly to the multi-trial analysis because we still have a long time or a long way to get to the realized genetic gain. In the multi-trial analysis, please notice that this time, when we select the timestamp and we select the traits, in the past, when I show you the multi-trial analysis, we were focused on fitting a blob model and a G-blob model and an RR blob model because the purpose of that experiment or that tutorial was to do genetic evaluation. And selecting materials requires that you use some of the fixed effect approaches. But to calculate genetic gain, we are not really that focused on selection, but just in checking the changes in means across the different generations. For that, this time I'm going to pick designation as a fixed effect as well. After that, it's important that you will notice that now the model is a blue. Then you can run the analysis. You will notice that now you get predicted values or means for the different materials, for the different environments, sorry, for the across environment. And this is exactly the input that we're going to use for the realized genetic gain module. Notice that now we are not interested on running an index or an optimal cross-selection because we are not trying to build a crossing block. We are just trying to monitor the changes in means across all these years for a particular historical data set. So you can go to realize genetic gain. And now you will notice that, of course, you always have an information tab. And in the input tab, it will ask you to pick a timestamp. In this case, the only timestamps that will allow you to pick is the ones for multi-trial analysis and for selection indices, which is the ones that you might be interested in calculating genetic gain. You will notice that there is also different methods to calculate genetic gain, the McKay and Piepos method, that you may have the references checked in the information tab. In the information tab at the bottom, you can see that the papers, the canonical papers can be checked. And those are the methods enabled here. The traits to be analyzed is going to be yield and ear height. And you can see that a visualization below the gray box where we specify the parameters is helping us to see if at least visually there seems to be any signal for yield and for ear height. You can see that the trait has not changed much across the different years. But still, we want to do the analysis formally. You can actually specify specific years that you want to focus for the analysis and the types of entries that you want to focus. Sometimes you want to do the regression, but you don't want to include checks. So you may want to remove the checks from the entry type. Remember that the entry type is a column that you match at the beginning, and it should help you to allow distinguish between the tested entries and the check entries. That way, you can just remove certain type of entries for the analysis. Also, you can remove certain years if certain years seem to be highly influential or they don't have enough individuals tested in that particular year or released in that particular year. Once you're good to go, you can just go to the Run Analysis tab and click on Run RGG or Realize Genetic Gain. You can see that this is a very quick module because it's just a simple regression of the adjusted means across environments for the different entries over the year of origin. You can see that the metrics that you receive include the slope of the regression, the intercept of the regression, the percentage genetic gain, the R-square of the model, the p-value, the number of trials behind this analysis, the initial year, and the last year of the regression. That exists for the different traits provided. The modeling is just telling us some specific parameters that you might want to specify before you run, like should the material be regressed or not, is it a partition model, etc., etc. Those input parameters also exist right before you run. There is additional settings that can always be changed. Going back to the output tabs, you can see that in the dashboard tab, you get a nice report summarizing in a table format the parameters or KPIs, where you can see that for this particular regression, there was 0% genetic gain, and also a nice regression plot showing the intercept, the slope, and the percentage gain. So you can see whether there has been change in the trait or not. You can see that there has been no change in these two traits because this is sample data that has been just mocked up and does not represent the real genetic gain of the Genomes to Fields initiative. At the bottom, you can always find the references because these reports can be exported by clicking on the Download Dashboard button. Once you click, you will see that an HTML is in your downloads, and this HTML can be shown to people even when you are disconnected from the application. You can see that when you double click on that report, it will open a tab in your browser. Then it will display the same metrics table and the regression plot for the different traits, so you can always show it to your collaborators. If you still want to save those results, you may want to go to data management, save analysis section, provide a name to your analysis, and click on save. That will download something with an object with an R data extension. That will go to your downloads. You can always use this object to upload it using the retrieve all analysis, so you can start where you stopped last time. At this point, I could just close my browser, close the application, and come back later, and I would exactly start where I stopped, just by retrieving that object. If you have any questions or concerns, feel free to go to the Home tab menu at the top, go to About Us, go to Contact and Development tab, and drop us a message in the support desk. We're happy to help you, and if you have additional questions, don't hesitate to reach us. Good luck with your analysis.